All right, so our next question is 26. If U1 is the potential energy of the planet-satellite system containing the satellite of mass M1, and U2 is the potential energy of the planet-satellite system containing the satellite of mass M2, which of the following expressions best represents the ratio U1 over U2? So the gravitational potential energy of a planetary system is defined as G M1 times M2 divided by R. So that's essentially the potential the force of gravity has to change the position of, or the potential energy that the gravitational force has on the object. So the way we solve this is we use U1 equals G M times M1 over R1, and U2 is equal to G M times M2 over R2. So when we put this together so that we have, so when we put this in a ratio, so we have U1, here, I'll show you what I just did there. So I have the potential energy of the first of the mass 1, which is G times the mass of the center object, so big M with no subscript, times the mass of the little object, M1. And then we have the same thing for the other planetary object, G times M2 for the mass of the little object divided by R2. Okay, so when we set up this ratio, we have U1 over U2, which is equal to GM M1 over R1 over GM M2 over R2. GM's cancel out. We get M1 over R1 divided by M2 over R2. Which is the same thing as M1 R2 divided by M2 R1. So the ratio U1 over U2 is equal to mass 1 times radius 2 divided by mass 2 times radius 1. So what this tells us is that the relationship between the potential energy of each of these two orbiting objects is their mass times the mass of one times the radius of the other divided by the mass of the other times the radius of the first. And that is the answer C for 26. M1 times R2 divided by M2 times R1.